More than 4 million square miles of open ocean are under the protection and jurisdiction of the United States, stretching from the Bering Sea off Alaska down the coasts to islands in the Caribbean and far in the South Pacific. The job of managing, exploring, and conserving the natural resources of those waters belongs to NOAA Fisheries, part of the National Oceanic and Atmospheric Administration, or NOAA.
These resources are so tied to the communities.
We can deploy sonobuoys, passive acoustic recorders.
Working from a small boat, we photograph all of the whales that we encounter
so that we can ensure that there are enough fish for everybody in the future.
I'm John Sheehan, and this is Dive In with NOAA Fisheries, a podcast about the efforts to keep marine life and their habitats healthy and sustainable, and the stories of the people doing the work. With scientists, policy managers, enforcement officers, and administrators based all across the country in regional offices, science centers, and labs, NOAA Fisheries works with commercial and recreational fishermen, industry, local communities, and partners to bring science-based decision-making and management to our oceans. And it's a huge job. As I mentioned, it involves managing millions of square miles of ocean, almost 100,000 miles of coastline, and supporting a $244 billion fishing industry. Add to that the protection and rebuilding of endangered marine species and habitats. It's an enormous undertaking requiring deep knowledge and understanding of ocean conditions. And that's why we're kicking off this show with one of the most foundational elements of NOAA Fisheries work: measurements, data collection, or as they're known in the agency, surveys. It sounds like sort of a humble thing, going out every year for decades and measuring ocean conditions, coral reefs, fish stocks, and habitats. But it is fundamental to the science-based decisions and actions that produce sustainable fisheries. It's also becoming much harder due to climate change.
Climate change impacts what we're looking at in the ocean at all levels.
That's Dr. Cisco Warner, Chief Science Advisor and Director of Scientific Programs for NOAA Fisheries. I wanted to talk to him about the challenges of conducting these surveys and collecting data at a time when climate change is affecting everything. And to illustrate this, we began with a climate event that, honestly, I barely remember, but it had huge ramifications.
New at 7, a mystery off of our coast has puzzled scientists.
Ocean waters have been warmer.
5 to 6 degrees warmer than normal.
And it may be a little bit more serious than its name implies.
It was dubbed
The Blob.
The Blob.
The Blob.
Dr. Cisco Warner, welcome to Dive In. Can we start with the blob? What was it? Why was it unprecedented?
Thank you, John. The Blob was an event that took place in the North Pacific between roughly 2013 and 2016, where there was an extreme warming of the upper waters of the North Pacific, ranging anywhere from off the west coast of the United States all the way up into Alaska. And the aspects that were unprecedented about the Blob was, first, how long it lasted. It lasted about 3 years. The amount of heat that was accumulated and how warm the waters became, and then the impact that it had on marine resources of all sorts. It caused shifts in fish populations, it caused shifts in marine mammal populations, in ecosystem structure. The heat was up to 2 to 3 degrees above normal, and it really exceeded anything we had seen in the past. One way to think about the warm blob was to look at it as a climate change stress test. The range of temperatures that we observed during the blob are in the temperature range that are expected under certain climate change scenarios. And these climate change scenarios are out into the future, several decades out. But we were able to experience or see how our ecosystems would respond if those climate change scenarios actually panned out.
So this was something that you hadn't planned on seeing for years and years in the future, and suddenly it was happening right in front of you.
Indeed, and the mechanisms may be different for how this kind of warming can take place. Warming can take place as global warming, meaning an overall warming of conditions. In this case, we believe that the blob was a result of change in atmospheric circulation patterns, and that's what made it special here in terms of creating conditions over this 3-year period that in some ways mimicked what could happen over longer periods under more gradual warming.
And just a quick note on the name. As I understand it, it was called the blob because satellite imagery showed this big mass of red sort of from the Bering Sea all the way down the west coast, right?
Indeed, that's the case, yes. One of our colleagues, Nick Bond from the Pacific Marine Environmental Laboratory, coined the term. And yes, it's a very conspicuous image that appears in satellite data when you see this red indicating way above normal temperatures in the satellite maps.
Wow. Are we still experiencing impacts from that blob?
Yeah, there are some impacts that continue. Some of the populations that shifted during that 2013-16 period, might not be rebounded to the normal conditions. Some of the abundances may not also have recovered to where they might have been before the blob. And also some of the shifts that we're seeing in populations further north in the North Pacific, going into the Alaska and the Bering Sea, are still beyond what would have been the normal distributions of Pacific cod or pollock, Alaskan pollock, before the blob.
And so what was the message? Like, what was the takeaway for scientists and oceanographers? I mean, what do you do with such an unprecedented event?
I think one of the things that emerged out of the blob is how quickly things can change. The reaction of the marine ecosystems, the reaction of the populations of targeted fisheries or protected species, and also the fact that perhaps we are close to reaching thresholds of certain populations in terms of their ability to tolerate changes in heat. So it might not take as much to cross these thresholds and have rather abrupt and significant changes in the populations. And so one of the things that emerged from the warm blob is needing to look at a number of possible changes that might occur, whether in distribution, whether in abundance, or whether the condition of the species, because it's not just that they're moving around, but also their food source might be different and their conditions might suffer from it. And so as we look into the future, we need to think about all of these scenarios together in terms of how we provide advice to management, in terms of what to do with likely outcomes of these changes that we're seeing.
And to give an idea of why that's so hard, can we talk a little bit about how historically these surveys had functioned and, how measurements had been conducted prior to this?
Yeah, the history of surveys in fisheries, you can start by thinking it somewhat simply, right? In the sense that in order for us to be able to manage our fisheries, we need to understand where the fish are, how many there are, the abundance, and also their condition. So starting with the first one, their distribution, we have a good idea of where we should be sampling. And that's important because that allows us to plan where our surveys should be, how much of an area it should cover, how much time we're going to be spending on the water, etc. In terms of when they're going to be there, that's also important. It's important to know that if I'm going to go out and look for a certain species in June, I can plan on that survey happening in June and make sure that survey fits in with a whole host of other surveys that we're doing. And then also we need to be able to sample what they're eating or what's preying on them. And so that brings in the ecosystem sampling part of the survey. In the past, or let's say if I go back 20 to 30 years, there was an idea that, yes, well, things always change and there's ups and downs associated with phenomena like El Nino or other things. These conditions are changes about a mean. So we understand that there's an average set of conditions that holds. What happened with the blob is that all of a sudden the fish weren't where they used to be. We had to sample areas that we wouldn't have gone to before. The timing of when the fish were there also changed. And so we needed to think about when do we go out to make sure that we sample the fish population that we're looking to estimate. And then ultimately, because the underlying conditions changed, we also had to say, well, how much more of the ecosystem do we need to sample to make sure that the population is sustained? And all of these three conditions are important in terms of determining how it is that we plan current surveys and future surveys, and understanding how these might evolve. how do we conduct these as we face these changes that are occurring very rapidly in our oceans.
Can you give me a sense of how physically the surveys are being affected? I mean, do you have to send out more ships? Do you have to use new technology that has never been used before?
Yeah, our surveys are being affected in every which way you can imagine. Surveys in the past focused largely on ship-based surveys, dedicated vessels that would go out for anywhere from a couple of weeks to 2 to 3 months with equipment on the ship such as trawl nets, which you put in the water and you actually sample the fish. You bring them on board and you can see how big they are, the condition they're in, how old they are. We use acoustic devices, so we use things like sonars, if you will, where the acoustic signals tell us where they are, how many there might be. And there's other ways that we, in the past, were able to sample our fish populations. Now that needs to expand. The fish are distributed more broadly, or they have shifted from where they normally would have been found. We need to try to keep the same surveys happening every year, so we have a reference point, but we also recognize that we need to potentially go to places we haven't gone before. And so we're relying on new technologies, such as uncrewed systems. And these are these gliders, for example, where they are self-propelled and they can cover parts of the ocean where ships are not going to be, because the ships are still trying to maintain that baseline that's important to maintain. But they can give us a sense of, are there fish now that are in places that we didn't see them before? How many might there be? And that in turn might cause us then to think about, where should we be thinking about measuring those populations with again, new technologies.
Yeah, we're talking about sort of water drones, right? Like uncrewed boats that are remote controlled, or do you just put them in the ocean and let them go and they come back in a matter of weeks?
Yeah, uncrewed systems can take different forms. One form is you can think of as almost look like a surfboard with a sail on it, and we will be able to, from shore, navigate the sail drone, in this case, sail drone being the company that builds this particular uncrewed system, and direct it to places where we think there might be populations that we need to sample or at least check to see whether those populations are there. These are surface gliders, yes, and then there are ones that are subsurface, because there are some where you are trying to measure what's happening deeper in the water. So there's a range of uncrewed systems that we're learning to use and are becoming operational. We also have to recognize that these are different ways of looking at the populations, different ways of measuring. And so we also need to calibrate, what does a glider tell us? What does an uncrewed system tell us versus what does a ship tell us? So there's a number of scientifically challenging, technologically challenging aspects of how we rethink our surveys that have to be considered as we evolve our ability to assess our populations and as we evolve our ability to continue to provide sound scientific advice.
And the last 2 years now, almost, has given us another wrinkle, which is the pandemic. How has that affected surveys?
The pandemic affected significantly our ability to collect data, particularly the year 2020, which is perhaps the peak of the pandemic. We were only on the water for about 400 days, when we normally are on the water close to 2,000 to 2,500 days. Some surveys were missed entirely, and that left a gap in these important time series that we use to understand these indices and fluctuations in the populations over time. What we did and what we needed to accelerate was our ability to use uncrewed systems and also grow our partnerships with industry to see how it is that we can still continue to collect data and try to make up for some of the gaps resulting from not being able to go out to sea on our ships. So, for example, we used uncrewed systems sent to parts of the Bering Sea in Alaska, and were able to sample, at least acoustically, where the populations might be and give us a sense of the abundance of what was out there. And a second partnership with industry was one that we conducted in looking at the bottom fish populations off Hawaii. We were able to collaborate with partners in the fishing industry to deploy camera equipment that would allow us to video the populations along the islands or around the islands. And using methods like artificial intelligence and machine learning, we were able to analyze that video in time so that we were able to continue to provide advice to management. So those are two examples that actually resulted in very positive outcomes that we are now continuing to use as a result of that positive experience.
Yeah, that sounds like quite a silver lining to a really awful period of time. Does it seem like that processes were pushed forward a number of years, that this change wouldn't have otherwise happened?
Yes, I believe that's the case, indeed. Our having to think about new ways and accelerating how we conduct some of our surveys as a result of the COVID pandemic was indeed one of the silver linings of an otherwise very difficult year. We're building on that, and we look forward to perhaps doing even more of that in the years to come.
And in the years to come, given climate change, given the state of the world, is there a new normal anymore, or is everything just shifting all the time?
That's a very good question, and it's one that resource managers broadly face, not just in fisheries, but also land-based resource management, largely as a result of the trend that we're seeing in global warming and climate change. There's a concept called stationarity, where changes happen and fluctuations happen. They happen about an average. Sometimes it'll be warmer, sometimes it'll be colder, sometimes it'll be drier, wetter. But on average, we know what to expect. We're entering a period which we now refer to as non-stationarity, where changes continue to happen, but they don't happen about a mean. They don't happen about an average. So increases, say, in temperature or changes in ocean acidification, and that's the trend itself is changing. Things might happen more frequently, so whereas things might have happened, say, once every 5 years or so, now they're happening every 2 years, and that, of course, then changes the ecosystem response to these changes. Sometimes they might not have time to recover. And also the magnitudes of things are different. Whereas things used to warm up a little bit or cool down a little bit, now these extreme highs and extreme lows are also more pronounced. And so we're entering a new world, a non-stationary world, where all of these factors need to be considered, and it does impact not just what we measure, but how we analyze it, and also how we provide advice to the managers and decision makers that need that advice.
Dr. Cisco Warner is Chief Science Advisor and Director of Scientific Programs for NOAA Fisheries. In the next few episodes, we're going to explore more about what makes performing these surveys and maintaining their data so integral to NOAA Fisheries' core mandates. And we'll do it by going where they're doing the work, the regional science centers across the country and globe. Stick with us. I'm John Sheehan, and this has been Dive In with NOAA Fisheries.